Hi, welcome to Kala's Math World. Today, let's see the sum prove that root 5 is an irrational number. What is a rational number? Any number that can be written in the form of P by Q, where P and Q are coprime numbers. What is a coprime numbers? The numbers which doesn't have any other factor than 1. So only 1 will be the factor for P and Q. Then we will call it as coprime numbers. And Q is not equal to 0. So this is the condition which will satisfy to say that P by Q, any number, is a rational number. So if it is an irrational number, we cannot write in this form where P by Q, P and Q are coprime numbers. So we cannot write in this form. So now we have to prove that root 5 is an irrational number. So this proof we will do with the contradiction method. That means you will suppose that root 5 is a rational number. So first step is suppose that root 5 is a rational number. So supposing like that, we can say root 5 can be written in the form of P by Q, right? So where this P and Q are coprime numbers, that is there is no common factors between P and Q, and Q is not equal to 0. So if you are able to write like this, then we can square this. So by squaring we will get it as root 5 the whole square is equal to P square by Q square, right? Now root 5 the whole square is equal to 5. So P square can be written as 5 into Q square, because root 5 square is equal to 5 and Q square I will take to the left hand side. Since Q square is in the denominator in the right hand side, when it comes to the left hand side, it comes to the numerator. So P square is equal to 5 into Q square we can write. So from this one we can say that 5 divides P square, right? So P square is equal to 5 into Q square. So P square is a multiple of 5. Then we can say that P divides P square. So this gives P also will divide P. So if any number is divides square number, then square root also will be divided with that number. So 5 divides P square implies 5 divides P also. So we will have 5 divides P also. So let's assume that P is equal to 5 into M, where M is any natural number. M is a natural number. Then we can substitute this in the equation number 1. So from equation number 1, we will get P square is equal to 5 into Q square, that is 5M the whole square is equal to 5 into Q square, right? So that means 25M square is equal to 5 into Q square. So this 5 and this 25 will get cancelled. You will get 5M square is equal to Q square. So with this equation number 2, we can say that 5 divides Q square, right? Because 5M square is equal to Q square, that means 5 divides Q square. This implies 5 divides Q also. So from here, from this A and from this B, we can say that 5 divides P and 5 divides Q also. So from A and B, we can say that 5 is a common factor of A and B, but we had common factor of P and Q, but we took P and Q as coprime numbers, right? So we assume that P and Q are coprime numbers. But here we got 5 is the common factor of P and Q. So that is a contradiction. This arises because we assume wrong. So what was our assumption? Root 5 is a rational number. So this contradicts the fact that 5 is a common factor of P and Q. That contradicts P and Q is a coprime number. So we can say that root 5 is an irrational number. Hence the proof. So I hope everybody understood the proof. So if you have any doubt, please message me in the comment box. Thank you.